Hello, I am Ana Paula Ruiz, and today I'll be presenting the problem situation 2 from the course of Application of Numerical Methods to the Built Environment. Well, in this following video, I aim to determine the area of a selected zone using the concepts learned in the Numerical Methods course. The area chosen to determine is Nassau. I chose this area, and I will be determining the area with the Gauss method. Nassau was chosen due to its geographic significance and availability of accurate data on Google Earth. Methodology involves selecting representative points along Nassau's perimeter, recording their coordinates in Excel, and applying the Gauss method for area calculation. A minimal margin of error is expected due to the precision and coordinates obtained from Google Earth. The results will provide a reliable estimation of Nassau's area relevant for various purposes. Well, I'll tell you a little bit about the area I chose, about Nassau. It is the lively capital of the Bahamas. It stands out among the 700 islands that make up the Commonwealth. Located in New Providence Island, Nassau's harbor has a blend of old world and colonial architecture, beautiful white sandy beaches, pristine turquoise waters, and a busy port. It holds a population of approximately 246,329 people, representing over 70% of the entire Bahamian population. Its land area consists around 1,137 square kilometers. Over here we can see the image in Google Earth of Nassau. What I did was apply several markers, several points all along the perimeter of the area. So each point we can get a coordinate, and after that we can import it to Excel and get the coordinates, precise coordinates. I'll talk a little bit about the method I use, which is the Gauss method, also known as Gaussian elimination. It is a systematic approach used to solve systems of linear equations. It involves transforming the original system into an equivalent triangular form through a series of row operations. This triangular form simplifies the process of finding solutions, often through back substitution. The Gauss method is widely applicable in various fields, including mathematics, engineering, and computer science, for solving these kinds of problems involving linear relationships. So for calculating the area, what I did was import all my coordinates after converting them into a format which is more easy to have in east in Y and north in X. So I did my whole table in Excel converting those coordinates. And after that, what I did was using the following formula, which uh, which is for determining the area of a polygon on a specific plane. Uh, well, tell you a little bit about this formula. A will represent the area of the calculated polygon. Sigma b will represent the sum of the products of consecutive x and y coordinates in a specific order. This is obtained by multiplying the x coordinate of each vertex by the y coordinate of the next vertex and summing these products. So that's what I did all along the second table in B. And well, sigma A will represent the sum of the products of consecutive x and y coordinates in the reverse order. This is obtained by multiplying the y coordinate of each vertex by the x coordinate of the next vertex and then summing these products, as we can see in the next image next to the formula. So the results will be seen in the second table in A and B. Well, after applying the coordinates, what I did, in the past slide, in the points and x and y, I made the table, and here we can see the perimeter of Nassau, and it's quite similar to the previous image we saw. So, we have the data over there. After we have the results of those sums, we will get the calculated area. For that, we will subtract A from B and divide it times 2. That result will give us our calculated area, which resembles pretty much from the real area we can see from now, which is the real area is 1,127 square kilometers. I converted that to square meters uh, so we can have the same values for both. So now we'll get the error percentage. We will calculate three errors: the absolute error, the relative error, and the percentage error. First, for the absolute error, we will subtract the calculated area minus the real area. Next, for the relative error, we will have the subtracted calculated area from the real area and divide it by the real area. Then for the percentage error, we will subtract again the calculated area minus the real area, divide that by the percentage error, and then multiply it times 100. So in the next slide, we will see our results. So over here are our results. For the absolute error, we got 13, 54, 55, 75, 0.5. And for the relative error, we got 0.01, 20, 19, 14, 4. And that gives us a percentage error of 1%, 1% 0.20, which is quite a minimum percentage of error. So that means that our calculations were pretty correct and really approximate to the real area. Well, concluding with this video, this study demonstrates the effectiveness of the Gauss method in accurately calculating the area of a geographical zone. By meticulously selecting representative points and applying the method's procedures, we achieved a minimal margin of error, confirming its precision and reliability. The Gauss method intuitive approach and straightforward formula make it a valuable tool for determining the area of irregular polygons, with wide-ranging applications in various fields. So that will be it. Thank you very much.